Good morning, everyone. This is BremSter, and today I'm coming to you with a puzzle called Circuit Sum by Ridhwan. This is a puzzle that was submitted and the testers said was good. They said they didn't like the cosmetics very much, and I can see why, but apart from that, they said that this is quite mathy and quite tricky, and that I should have a lot of fun if I can figure it out. So let's give this a look. So we have normal Sudoku rules apply. In every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Now, then we've got the circuit sum line. So digits at the endpoints of each blue line are the same and indicate exactly how many unique digits are on that line, including those endpoints. So for example, we know that these two digits are the same, and the digit in that line will give you the count of distinct digits on this line. So for example, if this was a 4, then it would mean that there are only 4 distinct digits on this line. So that's what that means. So there would be, that's what it means. I'm not sure how else to phrase that. And that includes the endpoints. So this is counting towards one of the digits. Blue lines are also region sum lines. So box borders divide blue lines into segments with the same sum. So we know that these 3 digits have the same sum as these 3 digits have the same sum as these 2 digits. Because there's a box border between these 2 parts of the line, which is here. The wording on this is okay. I think there's better wording for some lines, but again, there's been a lot of refinement since this was submitted. Then digits joined by white dots are consecutive and not all dots are given. So that's all the rules we have for the puzzle. I have solved a puzzle with this circuit sum line before. I'm not sure if it was by Ridhwan, and I know I struggled with it. So we'll see if I do any better this time. Restarting the puzzle to restart my timer. Let's give this a shot. So let's look at this long line. How many possible... Actually, I think this is not the line to look at, but how many possible digits could we have? Because these are the same. So we know these are the same digit, and yellow must appear in here by Sudoku, because yellow can't go in here or here. So that's already one digit is taking 3 spots on the line. So 1, we could have 2, 3, 4, 5, 6. So there's a maximum of 6. That's if all of the other cells are different. So the maximum this could be is 6. What's the minimum it could be? Well, could it be 3? So let's say, so there's at least 3 different digits. So let's say 3, 4, 5, or 6. Now, could it be 3? If it's 3, then these 3 digits would be the same as these 3 digits would be the same as these 3 digits. But that doesn't work because of the sum line. Because these 3 digits would be the same as these, and then these 2 digits, which have the same sum as these 3 digits, would have the same digit makeup. And this digit, it wouldn't work. One of these digits would have to be 0, because the sum of these 2 digits is the same as the sum of those 3 digits. And if these were the same digits as if these 3 digits were the same sum of these, how could 2 of them sum to the same sum as all 3? It doesn't work. This can't be a 3. So it's 4, 5, or 6. Can it be 4? Or should I be looking somewhere else first? Can it be 4? I think I'm starting on the wrong line here. Yes. Yes, I am. This can only be 2, can't it? Because there's a minimum of 2 digits on this. No, 2 or 3 actually, because these are the same digit, and therefore because these lines have the same sum, these are the same digit. So therefore, because if this was 3 and this was 3, this would be 3 plus x and 3 plus x. So these are the same digit because they have the same sum. So these are 2. Which puts 2 up here. This can't be a 2. These are the same digit. Let's use green. These are the same digit. And the minimum on this line is 1, 2, 3, 4, 5. So this is not a 2. The minimum on this line is 1, 2, 3, because these are 3 different digits on the line. That's not a 2. This is a 2. I don't need to color this because I know what it is. Okay, now, these are the same digit. I'll use orange there. And orange is in one of these two. So I'm going to uncolour that as green because I don't need it, because we know they're the same. That's what it's saying. But I know orange is one of those two. But I don't know which one. Wait a minute. 2 could be... What am I saying? 2 could be there. I did that wrong. 2 is one of those two. 2 could be there because that's not the end of a line. I'm already losing myself. 2 can't be here, but 2 could be here or here. This line is a minimum of 4 and a maximum of 6 because these are the same. So 1, 2, 3, 4, 5, 6. So these are 4, 5, or 6. But it's more restricted than that, isn't it? This digit, could it be, hang on, it can't be 6. 1, 2, 3, 4, 5. It can't be 6. It's 4 or 5. And if it was 5, 1, 2, 3, 4, 5, it can't be 4. 1, 2, 3, 4. So if this was, this and this are the same digit, and these are 4 different digits that can't be green, this is 5. Because these are all different, and neither, this can't be green, this can't be green, this can't be green, this can't be green. So these are 1, 2, 3, 4. These are 5. Which is interesting. No, they don't see yellow, unfortunately. So what's this? So this, minimum 3, 1, 2, 1, 2, 3, 4, maximum 4. So this is 3 or 4 only, because these are the same digit. So 1, 2, 3, 4. Because it could be 3 if those are the same digit. So 1, 2, 3, those are the same digit, those are the same digit. If those are the same digit and those are the same digit, it could be 3. Or 1, 2, 3, those are all different. So it depends on whether those are the same or not. But these 3 digits, I'm jumping all over the place here. These 3 digits, because this is 5 and this is 5, these 3 digits have the same sum as this. And the minimum these could be is 1, 2, 3. So this is 7, 8, or 9. Yeah, these lines are too close to the pencil mark blue. Now, if I was to put a 1 in the center there, that's almost invisible. Okay, if these were 4 different digits, how would that work? 4, 4, and 4 would be in here. Then I would have 3 different digits to play with. So there'd be 2 digits here, which would be... Now, let's look at this line first. So the minimum here is 5. 1, 2, 3, 4, 5. Because these digits, let's make this green, must appear in here by Sudoku. So 1, 2, 3, 4, 5, 6. So this is 5 or 6 only. This is 6. Because the minimum is 1, 2, 3, 4, 5, but the maximum is 1, 2, 3, 4, 5, 6. So this is 6. There are 6 different digits on this. And that doesn't see yellow either. So 1, 2, 3, 4, 5. All of these are different. So that doesn't appear in any of these. So that must be one of those digits, because it can't appear down here. And therefore one of those two digits. So it's not that one, because that is there. And we know 6 is in here. But this doesn't see yellow. But this digit is the sum of those two. I don't think that's a problem. It could be as low as 3. Yeah, it could be as low as 3. Actually, I don't think it can. Because if this is 3, this would be 1, 2, and 1, 2 would have to go in here. And I'd have 3 1s and 2s. Right. Whatever goes here sees 3 digits in this column. Because this digit can't repeat in the 2 digits here. Because this digit, the 2 digits here, and this digit are all different because of the 6. Because these couldn't be 5 because of this. So there are 3 different digits in this column. No, that doesn't work. Well, it can't be 1 and 2. So if this was a 3, this would be 1, 2, and there'd be a 1, 2 in there. That doesn't work. If this is a 4, this would be 1, 3, and there'd be a 1, 3 in here. That doesn't work. It can't be 5, 6. This is 7, 8, or 9. It's not a 2. This is the 2. I got this very wrong. Oh, I could see this couldn't be 2 earlier, because if this was a 2, these 2 digits would sum to this. So this is the 2. And this digit is 2 higher than that. Oh, these can't be the same digit. If these were the same digit, this would have to be 0. So these are different, and therefore 1, 2, 3, 4. These are 4. These are all different. So there needs to be 2 different ways of making up the digit that goes in here. So 7 could be 2, 5. I couldn't use 1, 6. I could use 2, 5 and 3, 4. 8 could be 1, 7. I couldn't use 2, 6 and 3, 5. And 9, I could use 1, 8, 2, 7 or 4, 5. Well, I couldn't use 4, 5 in here, but that still works. Okay. Do I have a similar restriction here? So this can't be a 1 because it's the sum of 2 digits. It can't be 2 because it's because of that. So 3, 4, 5, 6. It can't be 5, 6. 3, 4, 7, 8, 9. Now, if this is 3, I'd have to put 1, 2 in here. I'd have to put 1, 2 in here, and then I'd have to put 1, 2 down here, but I've just put a 3 in here. If this is 4, I'd have to put 1, 3 in here. I'd have to put yellow and 1, 3 in here, and then I'd have to put yellow and 1, 3 in here. That doesn't work. This isn't 4. So this is a 7, 8, 9 triple. So these are 1, 3, and 4. And these sum to 7, 8, or 9. And these sum to 7, 8, 9. But they have to be different, don't they? Because if these were if this was yellow and 2 of the same digit, this would be yellow and 2 in the same digit, and this would be yellow and 2 of the same digit. So these are different to these. Because if they were yellow and 2 of the same digit, yellow and 2 of the same digit, and these would be yellow and 2 of the same digit by roping, and that's broken because this isn't the same digit. So this is yellow and 1, 2, 3, 4, 5. This is a 6. That's really clever. And I'm hoping it's correct. So now 6 is in one of these. 6 is in one of these, but not here because that's that digit. So 6 is in one of those two. We know 6 is in one of those three. I don't know where 6 is in this box. It could be on here. This could be 1, 2, 6 if that's a 9. So now we're looking at this line. So the minimum is 1, 2, 3, 4, and the maximum is 1, 2, 3, 4, 5, 6. So this is 4, 5, or 6. And that doesn't see any of them. Because 5 is up here. Now, if this is 4, these would be 4 digits, and these 3 would be from the same 4 digits, but these 4 digits would have the same sum as 3 of the 4 digits. This isn't a 4. But I'm not sure what to do with the 5 or the 6. Oh, this is a 5 because the 6 is seeing it. This is 5 different digits. So these 3 digits have the same sum as those 2 digits. This digit has 2 digits on here that sum to 7, 8, or 9. If this is 7, how would I make the 2 7s work? I couldn't use 1, 6. I couldn't use 2, 5. This would need to be 6, 3, 4 because I couldn't use the 2 or the 5. In here, though, I couldn't use the 2, 5. And I couldn't use the 1, 6. This would also be 6, 3, 4, and this would have to be 6, 3, 4. This can't be a 7. If this is a 7, how do I make the 7 in here? I couldn't use 1, 6. I couldn't use 2, 5. It would be 3, 4. In here, I couldn't use the 1, 6 or the 2, 5. I'd have to use 3, 4. This would be 6, 3, 4. This would be 6, 3, 4. This would be 6, 3, 4, but that's a 7, 8, 9. This is not 7. If it was 8 in here, 1, 7 is possible, 2, 6 is not, 3, 5 is not. So this would be 1, 7. In here, I could use 1, 7. I couldn't use 2, 5. Sorry, I could use 1, 7. I couldn't use 2, 6. I couldn't use 3, 5. This would also 6, 1, 7, 6, 1, 7, and this would be broken as well. This is the 9, and there's no 9 in either of those. So these are 2 digits that sum to 9. They can't be, they can be 1, 8. They can't be 2, 7. They can't be 3, 6. They can't be 4, 5. These are the 1, 8. Now these can't be 1, 8. They can't be 3, 6. They can't be 4, 5. This is 2, 7, 6. Because the 2 doesn't see those. So the 1 is not in there, the 1 is not in there, the 1 is in here. So these are 1, 8. So what are these 2 digits? They see 1, they see 2, then it could be 3, they could be 4. They can't be 5, can't be 6, can't be 7, they can't be 8. 3, 4, 9 only. They can't be 3, 4, can they? Because if this is 3, 4, this is 1, 2, 4. No, that works. Because these would sum to 7. These would have to sum to 7. But these are 3, 4, 9. There's no 1 here. So this is a 3, 4, 9 triple, and I know what that digit is. 1, 2, 3, 4. This is a 5. No, I've broken the... Oh, no, it's not a 5. 5, 6. This is a 7. So this is a 7. 8, 9. 9 is on this line. So if this is 9, 3, these sum to 12. If this is 9, 4, these sum to 13. Don't know. But there's a lot of digits in here restricting this. This can't be a 6. If this is a 6, this would have to be a 5 or a 7, and it can't be. This is the 6. The 7 makes this the 8. These sum to 8. So they can't be 1, 2, 5. So these... Hang on, no, I've got that wrong. No, that's right, 1, 3, 4. The only two ways of doing it is 1, 2, 5 or 1, 3, 4. I have to use a 1. If I start with 1, it's 1 plus 2. I need another 5, so it's 1, 2, 5. I can't do that because there's no 5 available for many reasons. 1, 3, 4 works, and if I continue, I end up with 1, 4, 3, which is the same. If I don't use a 1, then it's 2, 3, 4, which is 9. So this is 1, 3, 4. These, well, I can't put a 1 on this dot. So 1 is in one of those two. I can't put 9 on this dot. There's no 9 available. These are 1 and 9, and I can't put the 9 there. This is the 9, this is the 1, this is the 3, 4 pair. So 3 and 4 are up here. The 4 is looking across, making that the 3 and that the 4. There's no 1 here. So this is a triple. 1, 2, 5. No, there is a 2. 1, 2, 3, 4, 5, 6, 7, 1, 5, 8. It seems wide open, doesn't it? So there's a 1 and an 8 in those. Oh, there's a 1 and an 8 in those. I can't put 1 or 8 in any of those. So this is the 5, and there's no 5 in here. This is a 1, 8. So 5 is in one of those two. This is very clever. The 8 makes this 7, and now I need 2 digits in here that sum to 7. They're not 1, 6. They could be 2, 5 or 3, 4. And in here, I need the opposite. 2 digits that sum to 7. They're not 1, 6. So they're 2... Oh, they're not 3, 4. So this is 2, 5, 6 because they're not 3, 4, 6. So this is 2, 5, 6, and I can't use 1, 6, 6. So this is 2, 5, 6, taking 2, 5 out of there. There's the 4, there's the 3. This is 2, 5, 6. And I can get rid of the green here. Actually, just get rid of... No. What just happened? Undo. I think all the coloring's gone. I can get rid of the yellow here as well. Okay. So 5 is in one of those two by Sudoku. So this line is the only line I haven't done. What about this dot? This can't be a 6. I was just thinking about this dot, and then I saw this one. This can't be a 6, because if this is a 6, this would have to be a 5 or a 7, and it can't be either. So if this is a 2, this is a 1 or a 3, and if this is a 7, it's an 8 or a 6. It can't be a 6. So this is 1, 3, or 8. Oh, this is 1, 3, 4. 1, 3, 4, 1, 3, 4. Roping makes this 1, 3, 4. They're the only places I can put them. So this is the 6. This is 1, 3, 4. And I can get rid of the corner marks. There's no 3 or 4 in that cell. That's the 1. This is the 3, 4. Now that's going to give me something. But this is roped. So if this is 5, 2, 7, can't put 5, 2, 7 there or there. This is 2, 7. Giving me a 2, 7 pair in the row. So this is not a 2, this is a 6, because it's not a 2 because of the 2, 7, it's not a 5. This is the 6, this is the 2, 5. The 4 comes out of here, the 4 comes out of here. This 5 makes this the 2 and this the 5. The 2 comes out of here. But I know what these 3 digits are. 1, 2, 3, 4, 5, 6, 8, and 9. But 6 isn't consecutive with any of those. That's the 8, 9. That's the 6, making that the 7, that the 2, that the 6. The 2 makes that the 7 and that the 2. Putting 7 right here by Sudoku. Trying to see what's happening in this box. This is still 2 higher than this. So if this is 1, this is 3. Can't be 2. If this is 3, this would be 5, and it can't be. Can't be 4. If it was 5, this would be 7, and it can't be. Can't be 6, can't be 7. This is 1 and 3. Now, let me check that again. If this is 1, this is 3. If this is 5, this would be 5 and 2. This would have to be 7, and it can't be. This is not the 5. This is the 5. Actually, what are these 3 digits? 1, 3, and 8? And it can't be a 3, so this is 1 or 8. But if this is an 8, 2, this would have to be a 10. This is the 1, this is the 3. That takes 3 out of here and here. The 1 looks up, meaning this is the 1. There's no 1 here or here. This is 1, 4, 8, or 9 for the row, but it can't be 1, 4. So this is, this is just an 8, 9 for the box. But the 8, 9 pair makes that the 1, which of course is consecutive with the 2, making that the 4, making that the 3, making that the 1. These pencil marks are almost impossible to see. The 3 means the 3 is not there. The 1 takes 1. Oh, I've already got the 1 in the box. This triple, 1, 2, 3, 4, 5, 6, 7, 3, 8, 9. There's no 9 there. There's no 3 there. There's no 3 there either because of this. So this is the 3. The 8, 9 looks across, making that the 1 and that the 8. So 13, 13, 13. 15, 15, 15. Don't know about this one yet, but 9 and 9. 13, 13. Okay, so whatever these sum to, which must be either 9, 3 or 9, 4. 9, 3, this would be 12. These would have to sum to 11. Well, I know what these, well, actually, I know what these digits are. 1, 2, 3, 4, 5, 6, 2 and 7. And these, 1, 2, 3, 4, 5, 6, 7, these are 8 and 9. So if this is 3 and 9, these sum to 11, which would be 9, 2. If this is 4 and 9, which is 13 minus 1, these sum to 12. Well, I can't make this a 7. This is too high. This is 2. And if it was 2 and 8, these would sum to 10. And I can't make these sum to 10. So this is 2 and 9, which is 11. These have to sum to 11, which is 3 and 9. So, which is 3 plus 9. That has to be that way. The 2 makes that the 7. The 9 makes that the 8. The 1 makes that the 8, which makes that the 1. Puts 1 in the corner by Sudoku. So these pencil marks, these digits on the line are so hard to read. It's easier when it's highlighted, but when you click off it, it's just, they're so close to the same color. These, well, I need to put 5 in this row. 1, 2, 3, 4, 5 and 7. These are 5 and 7. The 7 makes that the 5. That's the 7. There's no 5 there. This column is missing a triple. 1, 2, 3, 4, 9. So these are 3, 4, 9, must contain a 9. Don't know, but there's a 2 in one of those two. I think I've done all the lines and all the dots now. So 1, 2, 3, 4, and 8 go into those. The 4 makes that the 8 and that the 4, which makes that the 9 and that the 8, which makes that the 9 and that the 8. So this is a pair. 1, 2, 5, I think. The 5 makes that the 2 and that the 5. This is a triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no 7 or 8, or there's already a 7, 8 in the top row. So that's a 7, 8. The 7 looks up, making that the 8 and that the 7, which looks down, making that the 9 and that the 8. So these are a pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 2 and 3. So there's no 3 here. This is 4 and 9. The 9 makes that the 4 and that the 9, which makes that the 3 and that the 4, which looks back, making that the 2 and that the 3. The 4 looks down, making that the 3 and that the 4. That is the correct solution to Circuit Sum by Ridhwan, 2852. I really like these. I like the constraint of these lines. I don't like the graphics on these lines. These need to be a fainter color so that the pencil marks are readable. But I love the constraint. Very interesting stuff to think about. Oh well, it's the way the setter did it, and I've kind of given up on trying to improve the cosmetics. I spent 2 years trying to convince setters that making your puzzle easy to solve on, making the grid something rather than just the logic, was important, and they don't care. They just don't care. They don't care about the solving experience. They just want to showcase the logic they've put into a grid. And it's a battle I've lost. Nothing I can do about that. But the logic is very, very good. I love this puzzle. Thanks everyone for watching. Hope you're enjoying the content. And as always, good luck with your solving.